as the title might suggest, today I'm going to be talking about using techniques from business intelligence, marketing analytics, and user behavior research. And I'm going to talk about understanding what users are doing in your environment or your infrastructure or your application as kind of an approach to end user security. So taking this framework of thinking about user behavior and applying it to our domain here. We talk a lot in security, I think, recently anyway, about adversarial machine learning and model hacking and graph stuff that's super cool. And all of this stuff is really, really interesting. But I also think that there's like another branch, if you will, of data science, of analytics, that really...
Due to technical difficulties, a portion of this presentation was not recorded. We are joining the program already in progress.
Likely that if I want to send coupons out to all of these people who live in this state, I probably want to send coupons for the restaurant closest to each of those people to get the most like return on investment. So I can group them based on geography. I can measure the distance that each of these people have from each of these restaurants and take the shortest distance and send them a coupon for that restaurant. This is really simple. We'll come back to this later, so remember this example. So now I want to get into some machine learning terminology. And like I said, I think this will probably be pretty basic for a lot of you if you've done any sorts of machine learning, but if not, hopefully it will be helpful and kind of demystify some of it if you've heard terms thrown around. So I'll try to make this as not boring as possible. Okay, so there's two main categories of machine learning algorithms typically we talk about. We have supervised learning and we have unsupervised learning. So supervised learning is when we provide input to the model and we also tell the model what we expect the output data to look like. Not what we expect it to be, but just some kind of sense of what it will look like. So for example, take an example of a Bayesian spam filter. So here along the top, I'm providing, so I have some spam, I have terrible email, then I have ham, or not so terrible, just normal, good email. And I can label these as such. And then I can feed these to my classifier, and they now know my definition for spam and my definition for ham. Cool. So then I can take this other text down here, this other like set of emails, and I can feed it to my classifier. And based on the definitions I've provided, my classifier will assign a label to these emails, right? So it's kind of like if I tell you to draw an apple and I put an apple on the table in front of you or give you a picture of an apple. So I'm telling you both what I want from you, but also giving you an idea of kind of what that should look like. So contrast that with unsupervised learning. So this is when we provide input and we just let the model figure it out. We don't define the categories as we did in the spam classifier example, but we let the model do it for us. And a really popular example of this is using an algorithm called k-means to cluster handwritten numeric digits together. So we don't provide any source of truth. We just say, sort all of these into groups that look the most similar to each of the others, if that makes sense. And k-means is actually one of the algorithms we'll be talking about in a moment. Okay, data types. So categorical, these are categories. These are things that don't have numeric properties. And then numeric, I think that's pretty self-explanatory. They are numbers. So before we get into talking more about the results, I want to talk about imbalanced classes. And so this essentially is when the number of observations or data points in each of your classes or groups is not evenly distributed. This is a really, really important concept if you're wanting to do any sort of anomaly detection or detecting things that don't typically happen a lot of the time. So to kind of explain how this would work with MailChimp, so here's our user base, and these are normal users. The majority of all of our users, these are people who are just marketing their small business, they're creating landing pages for their like community group, whatever, they're doing normal stuff. And then we have these users. So these are the users that we're talking about. These are the ones we're interested in. They're doing bad stuff. They've been attacked, or they're sending malicious content. These are the ones that we really want to focus on. So if I were to randomly sample this data, and let's say just pull 10,000 users out of the entire MailChimp user base. The likelihood that the distribution of okay versus not so okay users would match this is really high. Like, I'm probably going to get the same distribution in my sample data set, which is great from a sampling perspective, but it's not so great from the perspective of training our model to recognize these, because there aren't enough examples of these if I just sample randomly. So that's something that we're going to have to address when we get into feeding data to the model. Okay, so now we're going to talk about the models. And I will say, I'm going to talk through this. This has been a trial and error process, and it's also still in progress. This work isn't finished. So it's not going to be like a super straight shot of just I did this and it worked. No, it's a little bit more real than that. So I hope that that's useful. Okay. So first, we have to figure out what data we're going to feed to the model. And there's a lot of options. This is obviously not all of them, but it's just a sample of them. There are tons of different ways I could look at this. And I eventually ended up filtering things down to something that looked like this. And you'll notice that these are mostly security related, or what I would consider security adjacent features. So I want to call attention to this specifically because this is where, in particular, if you've been in InfoSec for a long time, you've been in the security space for a long time, and you want to do stuff like this, this is where your expertise is so critical. And this is a place where you can really shine, even if you feel like you're not sure about the modeling piece of it, because you already have a sense of what might be important. Like, I chose these features because I thought, I feel like these are going to have some bearing on how users might be grouped. And they might have some bearing on whether a user is deemed more or less risky or at risk of being abused or attacked. And so I just want to point that out. Like, domain expertise here is really, really, really important and can save you a lot of time. So yeah, so I start with security only or security adjacent features, and seems like a good place to start. So this is kind of what my data looks like. This is a simplified version, of course, but you can see that I have two-factor status represented, and then the two other features that we talked about earlier, times found in breaches, and then the number of logins. And you can see how these accounts differ. One thing I want to point out here is that these accounts, this variable, the two-factor presence or absence, this is a categorical variable. I've encoded it numerically because I want it to work with a model that takes numbers, but these are categories, so just keep that in mind. So I started with k-means. I started here because this was really, like, I was just sort of sitting at my desk one day and I was like, this would be a cool thing to do. K-means is a thing to cluster. Okay, I'm gonna use k-means. That was literally how I selected this to begin with, okay? So, I mean, come on. Like, one of the cool parts about this type of stuff is that it's all sort of like, try stuff and see what happens. Like, there's experimentation to this, and so that's really fun. This part wasn't so fun, but anyway. So k-means, essentially, it's a distance-based algorithm, and I will point out, it only works with numeric data, so that will be important. But the way it works is just like the geographic segmentation that we talked about earlier. So it basically will take a distance measure of each of the data points. So these will be your cluster centers, the restaurants, and then it will measure the distance from each of those data points to each cluster center, and then assign each of those data points one of those clusters. Cool, okay. So I said that k-means requires numeric data. Well, most of a lot of the features that I had were categorical in nature, so I had to transform them. And there are a number of ways to do this, but I essentially encoded them each of these things as numeric values, because I was like, that seems like that'll work. So I ended up with what essentially looks like a sparse matrix of ones and zeros for these mostly binary categorical features. So k-means uses distances, right? So what could end up happening here is k-means is going to consider really close two objects that are actually very distant from one another, just because they've been assigned two close numbers. So just because two things have the value of 1 doesn't mean that they're close. It just means that was the only other option because it's a binary variable. So I stopped right here. I didn't actually go further with this. I was like, no, this is a waste of my time. I'm not going to do this. But it wasn't really a waste because it kind of made me think more about how this would work. So I was like, okay, I have categorical data. Let me find something that's going to work with that. Instead of trying to fit my data to this model, wow, that was a weird way to say that. Instead of trying to make my data work with this model, let me try and find a model that will work with this data. So I found k-modes. And k-modes is pretty similar in concept to k-means. But instead of distances, it uses dissimilarities. And so essentially, it quantifies the total mismatches between two objects or two data points. And the smaller that number, the more similar the two objects are. The larger, the less similar they are. Instead of means, it uses modes. So here's an example of the data that I fed to k-modes. Again, you can see a lot of this is binary categorical. There's a lot of other stuff that's over off the screen that you can't see. And so here's what I ended up with. All right, so after trying a number of different numbers of clusters, trying different ways of doing this, I ended up using 8 clusters just for no real reason. Let me be very clear, no real reason. Again, I'm just kind of throwing stuff together and seeing how well it works. And I ended up with this distribution. So each of these here, to orient you, these numbers over here on the left are the classes or the clusters. And over here are the counts of users who fall into each of those clusters. So you might think, as I did, oh my gosh, okay, these are the anomalies. It's 5 and 4 and 7 are the classes. This is what I wanted to find. That was not actually true. It ended up being that there were a couple of accounts that looked really similar. They just had different role-based like access controls, like one was a viewer, one was an author. So that wasn't quite as exciting as I hoped. And then I started reevaluating everything, like all of my choices. And so I went back to the drawing board, and I was like, okay, let's add some features. Maybe instead of focusing on security attributes only, maybe what I need to do, because the whole point of this is to generate kind of a holistic picture of a user and understand all of the attributes that that go into that, whether they're more or less secure. And it's not just security-related attributes. It can't be. That just doesn't make sense. And so I ended up adding a couple of other features, things like account size, so like how many email addresses or do they have saved in their account, how much do they pay us, do they pay us, and a couple of other things in addition to these security features. But then I wound up with both categorical and numeric data. So that's a problem because now I've got to find another algorithm. And I actually came across this, I don't want to call it obscure, but there's not a whole lot of stuff out there about it. I found this algorithm called k-prototypes. And it was introduced, I think, in a 1997 or 98 paper that was essentially for this type of problem, not necessarily security related, but clustering with mixed data types. And I was like, okay, you know what? This seems like this might work pretty well. And so I have my data. Both, you can see, we've got like a nice mix of different types of attributes. And okay, let's run it through k-prototypes. K-prototypes, by the way, works kind of, it's the same idea as k-means and k-modes, but it uses dissimilarity instead of just pure distance. So we now have this, and again, these are the clusters, and these are the counts over here on the right, are the counts of users that fall into those clusters. And so, okay, this looks a little more balanced than the results I got before, but it's still kind of, I'm not really sure what to make of it. So like, I'm curious specifically about clusters 1 and 7 just because they're small and they seem like they're outliers. And so I was just very curious, the security mind in me was like, okay, two-factor authentication. Maybe there's something different about them here. And there was. So these were the charts that I showed you earlier. And so cluster 1 and cluster 7, again, just two separate groups of users. And these two clusters had the highest rates of adoption of two-factor authentication across all of those clusters. So there's something. And then these, clusters 4 and 5, were the clusters that had the lowest across the board adoption of two-factor. And cluster 4 and 5, let me just go back for a second. So they're not the largest, but they're somewhat similarly sized, so that's kind of interesting as well. This is a really, I'm so sorry for the quality of this. This is really embarrassing. But there is also an extremely, extremely, extremely weak but positive correlation between whether someone pays us monthly, so has a non-zero average monthly payment, and whether they have some type of two-factor. You actually can't even see it on the projector because it's so slight, but it's there. So I feel like I'm on the right track. Okay, but ultimately, these results are still kind of imbalanced. So what am I gonna do? And so to be clear, from this randomly sampled data, these were 10,000 user accounts. It shook out to be about, I think, 13,000 accounts that could log into these accounts. There's a chance that the actual target class wasn't even represented in this data. So there's a couple of ways to deal with this, with the imbalance class issue. So one is oversampling. So this would be taking all normal users and and not so normal users, and basically creating copies of this not so normal, like these bad users, and inserting copies into a duplicate data set. So I would have the same or almost the same number of observations of the class that I'm really curious about and also just the normal user base. I could also do something where I undersample. So I could just cut this large normal user set and make it equivalent to the smaller, more interesting target set that I want to look into. I will say that I have a little bit of a hunch that this is probably going to work better, that oversampling will probably work better, just because I think giving whatever model a chance to see this much will probably help out a lot as far as giving extra visibility into kind of what these accounts look like and being able to recognize them. But I'm probably going to try this too, just because this whole thing is, in the spirit of just let's randomly try stuff. So I'll probably do that. And then I kind of want to, I've touched on the fact that this isn't finished. This is still where I stopped just there is essentially how far I've gotten in this research. So I want to talk about a couple of questions. I presented this to the data science folks at my organization a week or so ago. I got some really good questions, and I want to talk about those. So one of the big questions that I've gotten is, how are you going to evaluate the results of this, particularly given that you're using unsupervised learning? This is a really hard problem. Just like in general, across any domain, across any problem where you're using unsupervised, using clustering. Clustering is unsupervised. But a lot of it really depends on why you're using unsupervised clustering techniques to begin with. I keep saying unsupervised clustering. Clustering is unsupervised. There's not really a type that's supervised. So it really depends on why you're using this method in the first place. And unfortunately, most techniques that allow you to evaluate, formally evaluate the success of a clustering model, require access to some sort of, ground truth, some sort of labeled data. And so that's kind of tough. I could generate some labeled data myself because going back to the whole idea of domain expertise, I think I have a good idea of what constitutes a fairly secure versus a not so secure account. But again, that kind of almost defeats the purpose of feeding it to a clustering model to begin with. So I'm not really sure. I think this is probably going to take some manual review. I think I'll probably have to go through and just look to see, do the clusters make sense? Which doesn't really sound super cool and advanced, but that's the reality of what I'm probably going to do. And then another common question I get is, what other models have you considered? So all the models that I talked about here are centroid-based clustering. And so I'm probably going to try dbScan or some sort of density-based clustering model at some point. Again, I'm probably going to throw a bunch of things at the wall and see what sticks, just because I'm really curious how this will shake out. And what I'd really like to do is eventually, long-term, put this data into a supervised model. Use this to train a supervised classifier. And I'll probably do something like look into a random forest or some other type of ensemble model. So, and I think this is really the crux of this whole thing, is what is the point of this and how does this actually fit into the defensive security program at MailChimp? Like, how does this fit into what you already have? So ultimately, my goal for this is to, at the simplest layer, if you are a high-risk account, if we deem you high risk or you're a security risk, maybe we don't let you fail at login so many times. Or maybe there are certain things around the perimeter of the account that we don't let you do quite as much as we would an account that we deem not so much of a security risk. And that's super broad, I realize that, but part of it's going to be figuring out what that looks like. But really what I want to do is provide a heuristic for my team and for our anti-abuse team and anyone else who touches this type of problem to focus monitoring efforts on accounts that really need it. Because we have millions and millions of users, and it's impossible to catch everything. So if I can help carve out these groups, so one of them would be these kind of the accounts that I showed on the left side of the spectrum earlier, if I can help provide attention on those and give a spotlight to those, then I feel like I'm doing something to help my team. And that's really what I want to do. And no, this isn't perfect at all. This is just one tiny piece of the puzzle that, security is defensive security requires a layered approach. And this is just one more layer on top of other things that we are doing, that we will be doing, and that I hope will help both my team and other teams get to the important stuff quicker. So, thanks. And I think we definitely have time for questions, so I am up for that if anyone has any.
Just raise your hand if you want to give the mic. Get us in first. We'll get to you right after.
So you looked at 2FA to see if there was anything special about it. Did you look at the other variables as well to see if there's special things about them, or not yet?
Yes. So I can't really share all of it, but yes, there are definitely other pieces as well. That was just an example.
And so it looks like you're using Jupyter Notebooks, and
Yes.
that's been something that I think several of the speakers today have actually kind of demonstrated. So could you tell us a little bit about how Jupyter Notebooks have facilitated doing this kind of analysis for you?
Yeah, for sure. In fact, let me go back to one of the screenshots just as an example. So Jupyter Notebooks, if you've attended any of the talks in here today, you've probably seen some examples of this. But essentially, it's an interactive Python environment that allows you to break up your code into these neat little cells. And it provides kind of like a living document. You can reuse it. So I can plug in any type of other data set. Like I could just change what data this is and still run this analysis again. So it makes it really easy to continue to hand analyses off. It also has the nice benefit of I can create notebooks that have these types of visuals in them, along with Markdown and other types of text annotations, so that I can pass this off to my boss and I can pass this off essentially to an executive with this kind of content in it. So yeah, interactive environment, but also one thing that I really like about it is that it makes it easy to share that kind of stuff.
So did looking at either the medians or the prototypes or the means when you did your clustering give any insight as to what the clusters actually meant?
Yeah, so unfortunately, the way they kind of took shape was based on account attributes that could be found really evenly spread across different, which doesn't, I realize that doesn't make sense, I'm not explaining that well. Yes, but it wasn't super helpful for discerning why an account would be in one bucket versus another, if that makes sense.
Can you talk about security education for the users? And I mean, is there an outcome of the research? Are you retraining users? Are you communicating with them? changing the variables?
Yeah, so this is actually something I've been discussing with some folks very, very recently. We historically have been really careful about reaching out to users or suggesting proactive things, partly because, you know, let's say we decide we want to email everyone who doesn't have two-factor authentication on and be like, hey, lock your stuff up, like, what are you doing? That can also kind of have a different interpretation. People can think, they will see that and go, oh no, MailChimp sent a security thing, we're really concerned, this looks like it could, they might have been hacked, oh no. So there's a fine line, and we're still trying to decide where that line is. We're talking about it though, and I am fighting very much for us to be able to somehow talk to these users, all of these, and say, please do yourself a favor and turn on these types of security features that we offer. So yeah, it's a really hard I mean, it's, you know, there's the whole like policy versus what we want, so yeah.
First of all, great talk. I love seeing machine learning applied to like data science problems in the security world. And it kind of brought up for me like this question of like, what is the dependent variable in this model? Like, it seems like you have a lot of independent variables about users and not a ton that the model would even be able to pick up on in terms of outcomes. And so maybe just to build on the previous question, like, do you have metadata about the kinds of outcomes you're interested in, or is that just not available? Or like, what are you hoping to see at the end of this model, aside from identifying user accounts that are anomalies?
Yeah, so ideally what I would do, and I didn't really get into this in the talk just because there was a lot to cover, we have a known data set of accounts that have been attacked and taken over. I know what those look like. And so those are things that I want to go back and be able to potentially feed to some of the future models and say, can you discern whether these are good or bad? One interesting, I'm sorry I'm like going on about this, but one interesting problem that we have is when an account is attacked or taken over or abused in some way, almost immediately we have a team that reaches out to that user to say, hey, something happened, you need to change your password, you need to turn on two-factor, you need to set up these notifications. And so it's great for the user, but it kind of is unfortunate for this research because what happens is we don't get a picture of what that attacked user looks like at the time of attack. So that's actually an initiative I'm working on with some of our data engineers right now to get those account snapshots so that we'll be able to have that source of, okay, this is what they looked like. So I hope that answers your question.
So a follow on to that. Over here.
Sorry.
No, you're good,
Sorry.
you're good. So it seems as though you would have two types of malicious users. So the first type is an account that wasn't malicious, where their account got hacked, taken over, and now is being used for nefarious activity. And then you'd have the other type of malicious user account that was set up with the premeditated idea to use that account maliciously. Did you find anything from the clustering that would help identify or correlate with the first, those premeditated ones, I'd call them?
Yes. So this is actually another thing that I am working on kind of in conjunction with this. This is completely different. So the way those accounts look, those accounts that are created to be bad, they're just garbage, they look different. There are specific things about them that unfortunately I can't go into here, but there are definitely things about them that they can be very easy to detect. And so I don't want to say that's an easier problem, but in some ways it can be, because, particularly if it's something automated, if we see bot signups or things like that. We have some methods in place to deal with that. But this is a little bit harder because, or at least it's hard in a different way. And we haven't really spent a lot of time on this particular piece of it, which is why I'm focusing on that. That's also another a really big vector though, for sure. Yeah.
So it sounds like this is something that you had the idea and then you kind of have learned and evolved your knowledge of it as you've researched it. What kind of tips would you have for other people that are in their organization and might want to try to apply that to learn how to apply data science to their own internal problems, starting from kind of the same position you were starting at and trying to kind of follow in your footsteps?
Yeah, so that's a really good question. So One thing I will say is that I think I've been very lucky because MailChimp encourages a culture of experimentation. And so if I do all of this and it turns out to be, we can't really use this in production, we can't really do anything with this, that's still okay because we've learned something. So I will say, I will put that out as a caveat, but I would say, think about your user base or think about, what questions keep you up at night? And is there a way to somehow start thinking analytically about this? And I realize it's a lot easier said than done, but thinking through the lens of an analyst or a data scientist, what types of data do you have available? What can you query easily? What can you get through? Get your hands on data. Even if it's in a Google Sheet, if it's in a spreadsheet, it doesn't matter. Start getting familiar with it. Because the only reason I knew to go to some of these things was because I lived in an analyst role for so long. I knew what the user account landscape looked like. So I would say get really familiar with that. And then just start playing with things, start getting your hands dirty. Don't be afraid. So much of this failed, but I learned a lot from it, so.
I'm sorry, but I don't know if this is covered earlier before I was able to get in. But when you're doing this work, did you discover that there was a gap in data, so you had to go back and add new data sources in order to be able to get the correct sort of information?
Yes. Sorry, I wasn't sure if you had a second part to your question. Yes, absolutely. So one of those situations was in going through the different models, realizing that I needed not just account security related data, I needed just normal, what does your account look like? How much do you pay us? How many users do you have? Other types of just account attributes. But there's one piece, so I touched on this just a minute or two ago. We don't have data around what an account looks like at the time of attack. And so those values they're not timestamped and stored, essentially. When a user turns on two-factor, that gets updated, but we don't necessarily timestamp that and say this is the history, this is the change log of when a user enabled these things. And so that's something that I'm working on right now with our data team to get that in, because that's been huge. That's actually created a whole lot of extra work for this because that's something that I don't have, that source of truth. So does that answer your question? Okay.